Hello there and welcome back. In this video we are going to talk about production grid retries. I believe most of you have come into a situation where you had to make your code more reliable or error prone, or just make sure that one simple mistake or event will not bring the whole application down. And there are many ways that you can do it, but what I found recently was a module which is called Stamina. And I'm going to show you how you can do it. So let's call this stem. And inside this folder, I'm going to deactivate my previous one. We create a virtual environment called stem. And after creation, we are going to activate it. Dot fish. Come on. Source stem bin activate dot fish. All right, and we can create our code. Let's go ahead and create a new child node. So let's call this demo.py and start editing. But before we do that, what we have to do is to install Stamina. So in order to install it, what we have to do is to use the pip install Stamina. And if everything goes well, we should be able to try and just use it. So technically, there are many ways that we can use this module, but one way is going to be the definition of what kind of event and how we want to handle it. So for example, we have a site. Let me create a new Safari window and bring it here. And this is called http bin.org. And here what we can do is to hit a context root which is called status. And if we go ahead and hit the status with a code, so 404, you will see on the client side the response. So for example, what we would also like to do is to have the requests module installed and go back to NeoVim and import the requests module and import Stamina. And we can use it to decorate the function. So for example, let's call this, how should we call this? HTTP code check. And we say that we want to pass a code, which would be an integer. And we will return how should we call this? Requests that response object. And here what we want to do is to get the response from the requests.get, and we craft our URL carefully. So basically we copy this code, paste it here with Ctrl V, and what we have to do is to, let me turn off my camera. So basically we have to swap out this part of the code and we just pass it as an argument. And after that, what we can do is to use the return response. And now what we can do is to use the decorator, so stamina, and retry, and here with the on equals, and we have to specify an exception, and the attempt is going to be the number of retries. And let's go ahead and see the requests module Python exception classes. Or even it should be easier just to say that let me navigate to stem and use the source stem bin activate fish and start a Python interpreter, import the request module and the request get https http bin status and 404. Okay, raise exception, connection error. What is it that we want to do? So we have the HTTP bin. Let's just copy and paste it. Control V. And we would need basically an error. Actually, this also should work. So first we should try and use it this way. Let's copy it, go back to our editor, and on this error we want to give it 3 attempts. And technically what we have to do is to, let's add trying URL, and here we use the HTTP code check, and let's give it 404. Let's save it, and I go back from my shell and try to run it. Okay. So if we go back, you can see that stamina retry scheduled. And basically what it does is that it sees that the error was raised and caught, and it tried it or tried to perform it at the given number of tries, and after the third try it stopped the execution. Let's make it 5. 1, 2, 3, 4, 5, and there we go. So it was using it appropriately. If I write it back, so with the appropriate domain name, and try it, I said try it, you can see that it gave it 1 try, it succeeded, we didn't notice any error, so basically it let it through. So generally the idea is that you would define an event or an exception on which the given function will try to perform a given number of attempts. So, for example, you have like a not so good network connection and you know that it usually fails once or twice. And if you give it 5 attempts, you can make sure that on average you are good with this function. Yeah, and basically that's the generic idea. You also have the option to use context managers. So let's give it a context-based.py script, and just quit this one, and bring it to the front. So for example, if we import requests and stamina and say that for attempt in stamina.retry context on, and here we would need the exception, so connection error, Control V, with attempt, we would try to get a response from the requests.get and https http bin /status/ let's say 404. This is not going to be a function, it's just rather for the demonstration's sake. So let's give it the trying message. Exception is. So now if I go ahead and try to run the context-based demo, you can see that it is trying and so on, and it will try basically indefinitely. And what we can do is the following. So if I say that I'm not going to limit the retries to a specific number of requests, we can use like a timing. So it will try for 5 seconds, 10 seconds, or half a minute, and so on. And we can do it by importing the datetime module. And if I want, I can go ahead and say that the timeout is datetime dot time delta seconds equals to 5. So now we will have like a 5-second timeout. And if I run this once again, you can see that each one of them is supposed to, like, at least one of them is supposed to complete in 5 seconds. And we can also give this an attempt and give it 4. And we can use the contents based. So it either has 4 attempts or a maximum of 5 seconds of timeout. And yeah, so I don't really want to make this video too long, but this module is I think it's pretty awesome, and it's generally a good idea to have some kind of error mitigation or exception mitigation in your Python code, and this is basically one of the good things that you can use, which are already available. But anyway, if you look at these 2 source codes, you can see that one of the ideas is context managers, which you can implement on your own, and the other idea is the decorator functions, which is another way of approaching this problem. And technically that was all I wanted to show you. See you in the next one.